Today we'll start with some vocabulary in probability. When we have an outcome that's either in A or B, or both, we can call this as A union B. So union is what we're looking at. And the symbol for union is this U sign here. So I think for union, it's easy enough to remember the U in union is the symbol, and it looks like that. If an outcome is in both A and B, so this is just the both part of the union, we call this intersection, and that's the symbol for intersection. It's like the upside down U. I think one easy way to remember intersection is if you see it as intersection. That's an easy way to see it. In terms of Venn diagram, we can see the intersection is in the middle. That's A intersection B. Union will be everything that's in A and everything that's in B, including the intersection in the middle. So for an event, if we wanted to find A union B, so everything that's in A and B, we're obviously looking at everything that's in A, and then we're also looking at everything that's in B. And you can see that the middle bit here is being counted twice, once in A and once in B. So if we wanted to find A and B as a union, we need to take this away, take the middle bit away just once, so we don't count it twice. So the rule for A union B is everything that's in A plus everything that's in B, just like we did before. And then we take away the middle bit just once, so we're not double counting it. So we can use this rule. We call this the addition rule. It simply just comes from adding everything that's in A, everything that's in B, and not counting the middle twice. We can have situations where A and B have nothing in common, so there's no intersection. We can say these events are mutually exclusive, and the addition rule now to find A union B is just adding A and B together because there's no intersection. The last thing we'll look at today is what we call a complement of something. So if we're looking for the complement of A, we can use a symbol that's a little C that's on top. Another common way of using it would be a little dash on top like that. And what that means is we're looking for everything that is not A. So complement of A is everything that's not A. So everything that's outside, like out here, excluding A. One last thing I wanted to point out before we move to the example is that in union, we'll see this word or a lot. So with union, we're always looking for this word or, A or B. That means we're looking for the union. For the intersection, we'll see this word and. So if we're looking at A and B, we know that we're looking for the intersection. This is going to be really helpful to know. So this example here, we have 150 people, and we surveyed for the gender and the eye color, and this is the result. So first we're looking for, if we're picking a random person from this sample, what is the probability that someone has blue eyes? Just to make things simpler, we'll use A for people who have blue eyes, B for brown, G for green eyes, M for male, F for female. So setting this up at the start, and you do need to write it out like this. If there's lots of questions like this, this will be really time saving going forward. So you don't have to write all these words, rather you can just write a letter to represent something. So for example, we can just write for question A, someone that has blue eyes, probability of someone having blue eyes, we can just use letter A. And that's going to be, we're looking at people with blue eyes over here. So that's 60 people altogether. So it was 60, and we know it's out of 150. Oops. 150. So we just simplify that to 2/5, and that's all we have to do. The second question is, what's the probability that someone is male? So male is everyone here, so this row here. So we add all of these up, and then we get 60. So probability of someone being male is also 60 out of 150, so 2/5 as well. Now let's do C over here. C is male and has green eyes. So when we look at the word "and," we know we're looking for the intersection. So probability of someone being male and having green eyes, we can write it like this. And this, that we're looking at people who are male and then people who have green eyes. So this people just here. So it's 5 out of 150, which is 1/30. Next question, we have people who are female and does not have blue eyes. So this one just a little bit more tricky. So female and, so intersection again, does not have blue eyes. So blue eyes, we write it as A, but for this one it's the complement of A. So we can write it like this. For this one, we're looking for people who are female, so all of these, and then people, everyone except for the ones that have blue eyes. So we don't look at these 40 people there, but rather we look at this one, and this one. So we add them all up. We should get, that's 50. So 50 out of 150. So just 1/3. And next question has blue eyes or is female. So this means probability of someone having blue eyes, or means union, or is female, so F. So to find this, I think the best way to go about it is to set up how to find it. So to find A union F, we add up the probability of A and F together, and we take away the probability of the intersection, like we talked about at the start of this video. So then we first find the probability of A, so that's simply just people who have blue eyes, which is the 60 here. So it's the 60 out of 150. And then we get probability of F, so people who are female. So it's all of these people here, and they add up to 90 out of 150. And then we minus the intersection of female and having blue eyes. So the intersection of female and having blue eyes is the 40 people that are here. So we minus the 40 people here, like that. And all of this comes to 110 over. So we simplify to this, and that's the probability of A union F. Alright, the last thing we need to do is to find the probability of male and does not have green eyes. Probability of male, and was it and? No, it was or. So or is union and does not have green eyes. So complement of G. Again, we can set it up as a addition rule like this. But I'll show you a different way this time. So we are looking for everyone who's male or does not have green eyes. So everyone who's male already counts. And everyone who does not have green eyes also count. So everyone counts except for this 5 here. So it's going to be 145 over 150, which is 29 over 30. So doing these types of questions, you can do it setting it up this way, or you can do it by just sort of figuring out how many people are in this category. I think this way is safer. You won't miss anything. I think this way is a bit easier to miss things. But for this type of question, the context was pretty simple, easy to understand. So I was able to do it either way.